Next chapter, indices. Now, we've already learned that 3 raised to power 5 means 3 times 3 times 3 times 3 times 3. 2 raised to power 4 is equal to 2 times 2 times 2 times 2. The superscript numerals 5 and 4 are called indices. In singular, it is called an index. In general, a raised to power x is equal to a times a times a x times. For example, 16 is equal to 2 times 2 times 2 times 2, which is equal to 2 raised to power 4. 81 is equal to 3 times 3 times 3 times 3, which is equal to 3 raised to power 4. 125 is equal to 5 times 5 times 5, which is equal to 5 raised to power 3. And we can represent this information in the form of a tree diagram as shown on your screen. Let's talk about the laws of indices. Rule number 1. The rule of multiplication. When indexed numbers with common bases are multiplied, we simply add the powers or the indices. For example, 2 raised to power 4 times 2 raised to power 6. We have 2 raised to power 4 plus 6, which is equal to 2 raised to power 10. 3 raised to power 5 times 3 raised to power 2 is equal to 3 raised to power 5 plus 2, which is equal to 3 raised to power 7. 4 raised to the power of a third times 4 raised to power a third is equal to 4 raised to power a third plus a third, which is equal to 4 raised to power 2 thirds. And so in general, a raised to power n times a raised to power m is equal to a raised to the power of m plus n. Rule 2. The rule of division. When indexed numbers with common bases are divided, we subtract the powers or the indices. For example, 3 raised to power 5 divided by 3 raised to power 3 is equal to 3 raised to power 5 minus 3, which is equal to 3 raised to power 2. 4 raised to power 7 over 4 raised to power 2 is equal to 4 raised to power 7 minus 2, which is equal to 4 raised to power 5. And so in general, a raised to power n divided by a raised to power m is equal to a raised to power n minus m. Note that the bases must be the same, otherwise these rules will not apply. And so 3 raised to power 4 times 2 raised to power 3 cannot be simplified further. Rule number 3, the power of 0. Any non-zero number raised to the power of 0 is equal to 1. So 10 raised to power 0 is equal to 1. 25 raised to power 0 is equal to 1. A raised to power 0 is 1. X raised to power 0 is 1, and so on and so on. Rule number 4, negative indices. A number raised to a negative index is equal to the reciprocal of that number raised to the positive power of the same index. That is, x raised to power negative a is equal to 1 over x raised to power a. That means that 2 raised to power negative 5 is equal to 1 over 2 raised to power 5. 5 raised to power negative 5 is equal to 1 over 5 raised to power 5. And the reverse is also true. That is, 1 over x raised to power negative a is equal to x raised to power a, meaning that 1 over 2 raised to power negative 3 is equal to 2 raised to power 3. And 1 over 4 raised to the power of negative a third is equal to 4 raised to the power of 1/3. Rule number 5. The power of powers. When an indexed number is raised to another power, we multiply the powers. For example, 2 raised to power 3 squared. Squared means that a number is multiplied with itself. So this will be 2 raised to power 3 times 2 raised to power 3. And in the rule of multiplication, we know that we should add the powers, so that we have 2 raised to power 3 plus 3, which is equal to 2 raised to power 6. But instead of all that, our rule here tells us to multiply the powers, so that 2 raised to power 3 squared is equal to 2 raised to power 3 times 2, which is equal to 2 raised to power 6. So that 4 raised to power 5 and then raised to power 4 will be equal to 4 raised to power 5 times 4, which is 4 raised to power 20. And so generally, x raised to power m, then everything raised to power n is equal to x raised to power m times n. Note that all numerals multiplied or divided together in a bracket are raised to the power of that bracket. So that 2 times 3, everything raised to power 4, means 2 raised to power 4 times 3 raised to power 4. 2 over 3 squared is equal to 2 squared over 3 squared. And so in general, x times y raised to power m is equal to x raised to power m times y raised to power m. And x over y raised to power m is equal to x raised to power m over y raised to power m. Rule number 6, fractional indices. Now, consider 4 raised to power half times 4 raised to power half. According to the rule of multiplication, this is equal to 4 raised to power half plus a half, which is equal to 4. Let's call that equation 1. We also know that root 4 times root 4 is equal to 4. We call that equation 2. Considering equations 1 and 2, it follows that 4 raised to power half is equal to the square root of 4, which means 3 raised to power half is equal to the square root of 3. Equally, 5 raised to a third times 5 raised to a third times 5 raised to a third is equal to 5 raised to a third plus a third plus a third, which is equal to 5. Also, cube root of 5 times cube root of 5 times cube root of 5 is equal to 5. From these two equations, it means that 5 raised to power a third is equal to the cube root of 5. And so in general, x raised to power 1 over n is equal to the nth root of x. Let's talk about the applications of indices. Now we use rules of indices to solve simple equations. For example, find x in 3 raised to power x is equal to 9. First, we need all the bases to be equal. So we express 9 to base 3, and that will be equal to 3 raised to power 2 or 3 squared. And so 3 raised to power x is equal to 3 raised to power 2. And because the bases are similar, we equate the powers. So x is equal to 2. Another example, 3 raised to 2x minus 1 is equal to 9 raised to 2x plus 2. we express 9 to base 3. So we shall have 3 raised to power 2x minus 1 is equal to 3 raised to power 2 into 2x plus 2. Now we equate the indices since the bases are the same. 2x minus 1 is equal to 4x plus 4. And solving for x, it will be negative 5 over 2. Four over 8 raised to power x is equal to 16. We express all to base 2. 4 is 2 squared over 8 is 2 raised to power 3 and then raised to power x. Everything is equal to 2 raised to power 4, that is 16. So we shall have x squared over 2 raised to power 3x is equal to 2 raised to power 4. According to the rule of division, we subtract the powers. So 2 minus 3x is equal to 4, and minus 3x is equal to 2. We divide everything by negative 3, and we shall have x is equal to negative 2 over 3. Another one, 3 raised to power x, everything squared, is equal to 9 raised to power 2. We write them to base 3. We have 3 raised to power x, then squared, is equal to 3 raised to power 2, and then squared. So we have 3 raised to power 2x is equal to 3 raised to power 4. 2x is equal to 4, and x is equal to 2. How about this one? 56 raised to power 1 minus 56 raised to power 0. 56 raised to power 1 is equal to 56. And 56 raised to power 0 is equal to 1. So we have 56 minus 1, which is 55, and that is the answer. How about this one? Show that 27 raised to power third is equal to 3. Now we can show this in two ways. The first one, from the fraction indices rule, we know that x raised to power 1 over n is equal to the nth root of x, which means that 27 raised to power third is equal to the cube root of 27. And we know the cube root of 27 is 3. And therefore we have proved that 27 raised to power third is equal to 3. Alternatively, you can express 27 to base 3. That will be 3 raised to power 3 and then everything raised to power 1/3. From the rule of power of powers, we shall multiply the powers. So 3 raised to power 3 times a third is equal to 3 raised to power 1, which is equal to 3. And therefore we have proven that 27 raised to power third is equal to 3. Another example, write 64 raised to power negative a third as a fraction. From the rule of negative indices, 64 raised to power negative 1/3 will be equal to 1 over 64 raised to power a third. And from the rule of fractional indices, 64 raised to power a third is equal to the cube root of 64. And so we have 1 over the cube root of 64. And the cube root of 64 is 4. So our answer is 1 over 4.